students, welcome to Easy BTech channel, your guide for BTech and beyond. Today we will be discussing old questions of BEE. By using superposition theorem, the problem is using superposition theorem find the current flowing through 20 ohm resistor for the network shown below. This is the figure he has given. According to the superposition theorem, a linear bilateral network having a number of voltage sources, current sources can be the response of any one element is equal to the algebraic sum of the responses acting alone while the other sources are inactive. So in this problem, I am having two voltage sources, 100 volts and 200 volts voltage source I am having. So I want to find the current in the 20 ohm resistor I have to find. So what we will be doing? So here, case 1 is 100 volts is active, 100 volts is active, 200 volts is inactive, 200 volts is inactive. To make, so here 100 volts is active, case 1, 200 volts is inactive. To make a voltage source inactive, it should be shorted. So my diagram will be changing to so plus minus, this is equal to 100 volts, 40 ohm, 4 ohm, 16 ohm, and this is 20 ohm. So in the case 1, what is happening? 100 volts is active and 200 volts is inactive. So this is the modified diagram. So here what I can do is, here I am having 16 ohm and 4 ohm are in series. So what will happen? My R series is equal to 16 plus 4, which is equal to 20 ohm. My R series is equal to, now my diagram will be changing to, so this is the voltage source which I am having, plus minus 100 volts, 40 ohm, this is 20 ohm, and this is once again 20 ohm. Now by seeing the circuit, I came to know that 20 ohm are in parallel. So here I can write 20 ohm and 20 ohm in parallel. So I will be getting my R equivalent is equal to 20 into 20 divided by 20 plus 20, which is equal to 10 ohm. Now my diagram will be changing to, so this is how I will be changing my diagram. So this is plus minus, this is 100 volts, this is 40 ohm, and this is equal to 10 ohm. Now if I want to find the current here, so here I will be finding the current here. So this is the current I. So my total I is equal to V total by R equivalent. So which is equal to 100 divided by 50, which is equal to 2 amperes I got. So the total current in the circuit is equal to 2 amperes I got. Now I will be expanding the circuit once again. When I am expanding the circuit, what is happening? I am expanding the circuit. So here, when I am expanding the circuit, what is happening? This is equal to 100 volts, 40 ohm, 16 ohm, 4 ohm, this is 20 ohm, and this is equal to 16 ohm. Now here, current up to this is equal to 2 amperes. I want the current here, which is I1, and here my current is I2. I want the current I1. So I1 is equal to total current into opposite resistance, which is equal to R2 by R1 plus R2. In this case, which is equal to 2 amperes into opposite resistance is 4 plus 16 divided by 4 plus 16 plus 20, which is equal to 2 into 20 divided by 40, which is equal to 1 ampere. So the current in the 20 ohm when we are having 100 volts is 1 ampere I am getting. Is 1 ampere I am getting. Now, when I am coming to the case 2, 100 volts is inactive. 100 volts is inactive. 200 volts is active. So once again, my diagram will be simply here 100 volts is shorted here. So here I am having 200 volts, whatever the voltage I am having, plus minus, this is equal to 200 volts. This is 40 ohm. This is 20 ohm. This is 4 ohm and this is equal to 16 ohm. Now I want the current here. So here what I will be doing, here also what is happening, this 40 ohm and 20 ohm are in 40 ohm and 20 ohm are in parallel. 40 ohm and 20 ohm are in parallel. So my R equivalent is equal to 40 into 20 divided by 40 plus 20, which is equal to 800 divided by 60. So if I am using my calculator, 800 divided by 60, I am getting this as 13.33 ohm I am getting. Now what will happen to my circuit? My circuit will be changing to so this is equal to 13.33 ohm. This is 4 ohm, 16 ohm, and this is plus minus 200 volt I am getting. Once again, if I want to calculate the total current, this is my total current I. Here I will be considering this as I2. Now here what is happening? For this also, my I2 is equal to total voltage is 200. My R equivalent is 13.33 plus 4. 13.33 plus 4 plus 16, which is equal to 200 divided by 33.33. So here 33.33 divided by 200 divided by 33.33. So here I am getting this as 6.006 amperes I am getting. Now once again what I will be doing, I will be expanding the circuit. I am expanding the circuit. So when I am expanding the circuit, what is happening? Now here, this is my 20 volts. So this is equal to 40 ohm. And here I am having 4 ohm. This is 16 ohm. This is 20 ohm plus minus 200 volts. Now here what is happening? Up to this point, my current is 6 amperes. Now it is divided as I2 and here it is divided as I1. Now here I want the current I1 here. So once again here I will be using the formula. I1 is equal to total current is 6 amperes. For this opposite resistance is 40 divided by 40 plus 20, which is equal to 6 into 40 by 60. So here 10, here it will be 4 amperes. Now here what is happening? I can say here current in 20 ohms when 100 volts is active, 100 volts is active is 1 ampere. Next, current in 20 ohm when 200 volts is active is 3 amperes. So here the total response of current is, oh here I got 4, no? So is 4 amperes. So here 4 minus 1, which is equal to 3 amperes. So this is how we'll be finding the current in the 20 ohm resistor by using the superposition theorem. So here many people, they will be having the doubt, sir, how we are going from 4 minus 1. See here, in this case my current is going like this, but we have taken the current in opposite direction. That is the case here. Why I have written 4 minus 1, which is equal to 3 amperes. In the second question, find the form factor of a full rectified sine wave. Simply he will be giving, so we have to draw our own diagram, we have to draw. So here the full rectified sine wave will be, so this will be the diagram for full wave rectified sine wave. Here I am taking V of t. Here the maximum value is equal to Vm 0, pi, 2 pi. This is the case he has given. Simply is asking to find the form factor of the full rectified sine wave. So here I know form factor is equal to RMS value by average value. So here in this problem I will be calculating the average value as well as the RMS value. So here the function which he has given is V of t is equal to Vm sine omega t, which I will be writing this as Vm into sine theta I will be writing. Now, according to the definition, I am having V average is equal to 1 by t integral 0 to t f of t into dt. This is the function which I am having. So here what I will be doing, 1 by pi integral 0 to pi. Here my f of t is nothing but simply Vm sine theta into d theta I am having. So here if I am further simplifying, this I will be writing as Vm by pi integral 0 to pi sine theta into d theta I will be writing. So the integration of sine theta is nothing but simply minus cos theta. So here if I am going up, here this I can write this as, here Vm by pi in the limits minus cos theta, limits are 0 and pi. If I am substituting the limits, I will be getting Vm by pi into minus cos pi minus of minus cos 0. So here I will be taking this as a note, as here I will be taking a note, or simply I will be writing the note as note cos pi is minus 1, cos 0 is 1. So here simply what is happening, which is equal to Vm by pi into minus of minus 1 plus 1, which is equal to 2 Vm by pi is the solution which I am having. This is about the RMS value is this value. Now, when I am coming to the RMS value, I am having V RMS is equal to, once again, 1 by t integral 0 to t V of t whole square into dt total under root. This is the value which I am having. So here what I will be doing, here also square root of 1 by pi integral 0 to pi, and here I am having v of t is equal to Vm sin theta whole square into d theta I will be writing. So if I am squaring on both sides, for the time being what I will be doing, I am squaring on both sides. When I am squaring on both sides, v square RMS is equal to 1 by pi integral 0 to pi Vm into sin Vm square sin square theta into d theta I will be having, which I will be writing as 1 by pi integral 0 to pi Vm square sin square theta I will be writing as 1 minus cos 2 theta by 2 into dt I will be writing. This is one method what I am having. Now here, what is happening? Vm square I am removing outside. Vm square by pi. Now I am separating this integral 0 to pi 1 into d theta minus integral 0 to pi cos 2 theta. This 2 also I will be taking outside into d theta. These are the values which I am having. Now here, what will happen, ma? Simply, here I am having this as Vm square by 2 pi, as it is I will be having. Integration of theta is theta only in the limits 0 to pi minus the integration of sin 2 theta is sin 2 theta by 2 limits 0 to pi I am having. Now if I am substituting the limits, I will be getting Vm square by 2 pi. Here pi minus 0 minus sin 2 into pi by 2 minus sin 2 into 0 by 2 whole I will be getting. But here, one thing which you have to remember here is, see here ma, what is happening? This total value will be equal to 0. Why? Because sin even pi, that is nothing but simply sin pi, sin 2 pi, so on, it will be equal to 0. So this total value is equal to 0. So what I have left with? I have left only with, which is equal to Vm square by 2 pi into pi. So pi will be cancelling. I am having V square RMS is equal to Vm square by 2, or simply here I will be writing this is equal to V RMS is equal to Vm by root 2 I will be writing. So here I have calculated the average value as well as the RMS value. Now he is asking to find the form factor. So here what I will be doing, form factor is equal to RMS value by average value. RMS value by average value. My RMS value is Vm by root 2 divided by average value is 2 Vm by pi I am getting, which is equal to Vm by root 2 into pi by 2 Vm. Vm will be cancelled. So simply I will be having with pi by 2 root 2, which is equal to 1.11. So this is how we will be finding the form factor of a full rectified sine wave. Welcome to Easy BTech channel, your guide for BTech and beyond. So today we are solving if the form factor of a current waveform is 2 and the amplitude factor is 2.5. Find the average value of the current if the maximum value of the current is 500 amperes. So what is given? What are the values which he has given? So simply here my solution or simply answer given is form factor. My form factor is equal to RMS value by average value. Next, once again, amplitude factor is same. Amplitude factor or peak factor both are same. So here I will be writing amplitude or peak factor, which is equal to maximum value by RMS value. These are the formulas which I am having. So here, according to him, what he has given my average form factor. From this, what is happening? P amplitude factor here 2.5 is given, and my maximum value is equal to 500 amperes. So 500 amperes by RMS value. Yes, given as RMS value. From this, can I write my RMS value? From this, I will be writing my RMS value is equal to 500 divided by 2.5. So if I am using my calculator, 500 divided by 2.5, which is equal to 200, I am getting. So RMS value is equal to 200. And one more thing, what he has given my form factor 2. Form factor he has given as 2. So 2 is equal to RMS value, which is equal to 200 divided by average value. So here what will happen? My average value is equal to 200 divided by 2, which is equal to 100. This is my average value. Welcome to Easy BTech channel, your guide for BTech and beyond. So here in the problem is asking, find the current supplied by 10 volts battery for the following network. All the resistors are in ohms. I want to find the current which is supplied by the 10 volts battery. So here I will be using KVL. I will be using my KVL. So here, first of all, I will be naming the circuit as A, B, C, D, E, F, G, H. And I am taking the currents. Here, my current is I1. Here, my current is I2. Here, my current is I3. Now, I am applying KVL here. So here, first of all, I am applying KVL. Apply KVL for C, D, G, H, C. That means I am applying KCL for C, D, G, H, C. So here I am using the sign convention. In the resistor, when we are moving in the same direction of the current in a resistor, there is a drop in potential. Whenever we are moving from high potential to low potential in a voltage source, there is a drop in potential. And whenever we are moving from low potential to high potential, there is a rise in potential. In this case, what is happening? Minus 2 into I1 minus I3. Minus 12 into I1 minus I2 plus 10 is equal to 0. See, minus 2 into I1 minus I3, minus 12 into I1 minus I2, and here I am going from low potential to high potential. There is a rise in potential. Next, I am applying KVL for DEF, G, D. DEFG. So here also what will happen? Minus 3 into I2 minus I3. Minus 3 into I2 minus I3. Minus 5 into I3. Minus 12 into I2 minus I1 is equal to 0. So this is my first equation. This is my second equation. Next, apply KVL for A, B, F, D, C, A. That means from wherever we have started, there only it is ending. So here what will happen? Minus 4 into I3. minus 4 into I3 minus 3 into I3 minus I2 minus 2 into I3 minus I1 which is equal to 0. This is my third equation. This is my third equation. So after writing my KVL equations, we will be, after simplifying, I got equation 1 as 14I1 minus 12I2 minus 2I3 is equal to 10. Minus 12I1 plus 20I2 minus 3I3 is equal to 0. 2I1 plus 3I2 minus 9I3 is equal to 0. That is nothing but simply my third equation. So here what I will be doing, by using my calculator and using three unknowns. So here A1 is equal to 14 minus 12 minus 2 is equal to 10. Minus 12, 20, minus 3, 0, 2, 3, minus 9. So here I got the value of I1 is equal to 1.95 amperes. I2 I got as 1.30 amperes. I3 I got as 0.8695 amperes. So here in the circuit we have taken the current in 10 ohm is the current which is supplied by the 10 volts is I1. So simply my final statement will be current supplied by 10 volts source is 1.95 amperes. So this is how we'll be finding the current supplied by the 10 volts battery. Welcome to Easy BTech, your guide for BTech and beyond. In this problem is asking, by using Norton's theorem, determine the current through 5 ohm resistor for the circuit shown. The statement of the Norton's theorem: a linear bilateral network having a number of voltage sources resistances can be replaced by a simple equivalent circuit having a current source in parallel with the resistance. The current source is said to be the Norton's equivalent current and the resistance is said to be the Norton's equivalent current, which is found by making the voltage sources as short and current sources as the open circuit. Now here is asking to find the current in 5 ohm resistor. In whatever resistor is asking to find the current, that resistor I will be consider as load resistance. So here consider 5 ohm as RL, load resistor. Now I have to short circuit my load resistor. So my diagram will be simply this is the short, and here I am having a voltage plus minus 100 volts, 2 ohm, 12 ohm, 3 ohm, and here as it is shorted, here I am having IN. I should find the value of the current IN. I should find the value of the current which is said to be Norton's current. So here by seeing the circuit I came to know that this 3 ohm and 12 ohm are in parallel. So 3 ohm, 12 ohm are in parallel. So here what will happen? My R equivalent is equal to 3 into 12 divided by 3 plus 12, which is equal to 36 by 15. So here once again I am using my calculator. 36 divided by 15. 36 divided by 15. I am getting my equivalent here as 2.4 ohm I am getting. Now here further I can reduce the circuit as, I have reduced my circuit this as, so this is the current which I am having, plus minus 100 volts, this is 2 ohm and here this is equal to 2.4 ohm. This is equal to 2.4 ohm. I have to calculate the total current here. So my I total is equal to 100 divided by 2 plus 2.4, which is equal to 100 divided by 4.4. So here the problem, by using Norton's theorem, find the current. So in whatever the resistance is asking to find the current, that we have considered as RL. So here it should be short circuited. So here short circuiting RL. So this is the diagram which I am getting. I have to find the IN value. So by seeing the circuit, I came to know that this 12 ohm and 3 ohm are in parallel. So R equivalent I got as 2.4 I got. Now, when I have further simplified, my circuit is 2 ohm and this is 2.4 ohm and this is equal to 10 ohm. When I am calculating the total current I of t, by I of t is equal to 10 by 4.4. So here 10 divided by 4.4, I am getting this as 2.27 amperes. I am getting 2.27 amperes. I am getting. Now here I don't want the value of total current. No, so here what I will be doing, I will be writing or I will be simplifying the circuit here once again. So when I am simplifying the circuit, I am expanding the circuit here. So this is 10 volts, 2 ohm, 12 ohm, this is 3 ohm, and here my current is IN. Now here what is happening? According to the problem, the total current here which I am getting is 2.27 amperes is the total current which I am getting. Now here, this current is dividing here as I1 and IN. I should get the value of IN. So here, my IN is equal to total current, which is equal to 2.27 into opposite resistance is 12 divided by total resistor, which is equal to 12 divided by 12 plus 3, which is equal to 2.27 into 12 divided by 15. Here I am getting the value as 2.27 into 12 divided by 15. So here I got the current as 1.816 amperes. So my IN value is equal to 1.861 amperes is the current which I am getting. Now I should get the value of the Norton's equivalent resistance. So here I should get the value of the Norton's equivalent resistance. So here to find the Norton's equivalent resistance. So here my simplified diagram will be as I said, voltage source is shorted. So here this is equal to 12 ohm, 2 ohm, 12 ohm, and this is equal to 3 ohm. This is A and this is B. So from open circuit terminals, I should get the value of RL. From open circuit. So here, when I am seeing the circuit from here, what is happening? This 2 ohm and 12 ohm are in parallel. So here, I can write 2 ohm, 12 ohm are in parallel. So here, what is happening? My R equivalent is equal to 2 into 12 divided by 2 plus 12, which is equal to 24 by 14. So 24 divided by 14, I am getting this as 1.71 ohm I am getting. 1.71 ohm I am getting. Now here, further if I am simplifying, so what will happen? This is 3 ohm I will be having. This is A and this is B. The equivalent of 2 and 12 is 1.71 ohm, and here this is equal to 3 ohm. From here, I am seeing the value of Rn. So here I can write my Rn is equal to 3 plus 1.71, which is equal to 4.71 ohm. 4.71 ohm is the total equivalent resistor. Now here, according to my Norton's theorem, I should have the total circuit should be simplified by a simple equivalent circuit having a current source in parallel with a resistance. So this is the current source. So here I got the value of, what is the value of IN here I got? IN is equal to 1.81 amperes I got. 1.81 amperes I got. And here the total resistance which I got is 4.71 ohm. Now previously across this I was having 5 ohm. Now in the problem is asking to find the current in 5 ohms. So here this is equal to I1 and this is equal to I2. So simply I can write current in 5 ohm is, total current is 1.81 into opposite resistance 4.71 divided by sum of the resistances plus 5, which is equal to 1.81 into 4.71 divided by 9.71, which is equal to 1.81 into 4.71 divided by 9.71. So here 0.877 amperes. This is the total current in the 5 ohm resistor. So 0.877 amperes is the total current in the 5 ohm resistor by using the Norton's theorem. Here in the problem is asking find the form factor of a half rectified sine wave. So how my half rectified sine wave will be there? So once again this is equal to omega t. This is V of t. This is Vm 0 pi 2 pi. So here he has not given any function, so I am writing my V of t is equal to Vm sine omega t, which is nothing but simply Vm sine theta. Vm sine theta. So here I should find the value of average value as well as the RMS value. So once again I am having V average is equal to 1 by t integral 0 to t V of t into d theta. So here my function, what will happen? I am having from 1 by 2 pi. So in the integration from 0 to 2 pi, I will be dividing this as 0 to pi. From 0 to pi, I am having the value which is equal to Vm sine theta into d theta plus pi to 2 pi. From pi to 2 pi, the value of V of t is equal to 0. So this is equal to 0. So here, what I am remaining with? I have remaining with, which is equal to 1 by 2 pi integral 0 to pi Vm into sine theta into d theta, which I will be writing as Vm by 2 pi. I will be writing Vm by 2 pi. Integration is nothing but minus cos theta integral 0 to pi. So here what will happen? Vm by 2 pi minus cos pi minus of minus cos 0, as I said previously also, which is equal to Vm by 2 pi. Here minus of minus 1 plus 1, which is equal to Vm by 2 pi into 2. So 2 will cancel. I am getting by Vm by pi. So here the average value is equal to Vm by pi. In the same way, if I am going for Vrms is equal to square root of 1 by t integral 0 to t f of simply v of t into some d theta. So here what will happen? First of all, I am squaring on both sides. When I am squaring, what will happen? This value will be v square RMS is equal to 1 by 2 pi integral 0 to pi. My v of t is nothing but Vm sin theta whole square into d theta, which is nothing but 1 by 2 pi integral 0 to pi Vm square into 1 minus cos 1 minus cos 2 theta by 2 into d theta. So further, if I am simplifying, so sin square theta can be written as 1 minus cos 2 theta by 2. I can write 1 minus cos 2 theta by 2. So here what is happening? Vm square, I am bringing out Vm square by 2 pi. I am bringing out this 2 also. If I am bringing out, this is 2. Limits 0 to pi 1 into d theta minus integral 0 to pi cos 2 theta. I am having. So in this case, what is happening here simply, which is equal to Vm square by 2 pi. Integration of 1 into d theta is theta. Limits are 0 and pi. And here I am getting this as, this is 2 into 2. And here I am getting this as sin 2 theta by 2 limits 0 and pi. Now, when I am substituting the values here, what I will be getting here? Simply listen here, ma. I am getting this as Vm square by 4 pi. Here, pi minus 0 minus sin 2 theta means in the place of theta, I have to substitute sin 2 into pi minus sin 2 into 0. So as we have said previously, the total value of this is equal to 0. As I said, sin even pi's, 2 pi is 3 pi 4, sin 2 pi 4 pi will be 0. So simply here I will be having Vm square by 4 pi into pi. So pi will be cancelled. So I will be remaining with Vm square by 4. I am having V square RMS is equal to Vm square by 4, which is equal to V RMS is equal to Vm by 2. This is the value which I got. Now here, but he is asking to find the value of form factor. So here, form factor V RMS by V average. So here my RMS value is Vm by 2 and my average value is Vm by 5. So here Vm by 2 into pi by Vm. So which is equal to pi by 2. So if I am taking the pi value as 3.144 or which is nothing but simply 22 divided by 7, which is 3.44 divided by 2. So here I am getting as 1.5714. This is the total form factor of the half rectified sine wave.